How you going, guys? Curtis from Cutting Edge Engineering. So today we're going to be making a new shop made tool. What we need to make is a roller deforming tool to lock a bearing in position. And the bearing we're going to be installing is going in this support carrier for a torque converter out of a 637 scraper. And this is a bearing sleeve. It is made from white metal, so it is extremely soft. As you can see on the inside, there is a groove in there. Not only is that for oil, that is the groove we are going to be deforming to lock this into the groove into the support carrier. So the OEM does supply a procedure on how to install a bearing and a basic idea on how to make the tool, but that paperwork was last updated in 2002, so that is 23 years old, and I think we can make one a little bit better. And to make the tool, we're going to be using an off-cut piece of 1 3/4 chrome bar. I didn't want to have to order anything in, and this is the smallest diameter I had floating around the workshop. But we do need to turn down the OD and do a bit more machining, so we're going to get it set up in the lathe. The first thing I'm going to do is center drill the end. That way I can support the bar with the live center in the tailstock while we turn down the OD. So we're going to machine this down to about 32 mil, and that is so it fits in our tool post. And I'm going to machine that to a length of 150 mil. Now with that done, we're going to part it to length. Now we got that parted to length, we're going to get it set back up in the lathe so we can machine a spigot on this end. I need to machine the ID of this spigot to exactly 12 mil, and that is to suit the ID of a ball bearing. So that's close enough to 12 mil. I'm just going to chamfer these edges and cut the groove for the external circlip.
Cute.
The circlip we're using is 1 mil wide, so I'm just going to change out my grooving insert. Because the width of our ball bearing is 10 mil, I'm just going to touch off on this face, move across 10 mil, and then we can machine our groove. And I'm going to machine that to a depth of 0.65, which is 1.3 off the diameter. So that's that end completed. I'm just going to flip it around and chamfer the other end, and that will be the lathe work completed on the bar. Now with that done, we're going to take it over to the mill and mill the two flat so this can be clamped into the tool post. And to machine the flats, I'm going to be using a 16 mil 4 flute end mill. I'm going to touch off and then zero out my Z axis and then move the table up 1.5 mil and take the cut in one pass. Now I'm going to rotate this 180 degrees, move my table up another 1.5 mil and take our cut. Righto guys, so that's the bar for our tool completed. Really happy with how that turned out. The next thing we need to do is make up the roller that deforms the bearing sleeve. And to make that, we're going to be using the same piece of off-cut material we used to make the bar. First thing we're going to do is drill and bore the ID to suit our ball bearing. So I'm going to bulk out the material using a 27mm U-drill. Now we're going to bore it to size, and to do that I'm going to use a very cute 12mm boring bar with an ECGT insert. And we're going to bore this to 32mm, which is going to be size for size on the OD of the ball bearing. So I'm going to use my internal snap gauge and micrometers to check the measurement. That's measuring at 31.97mm, which means we have 0.03 of a mil to remove. I've got that measuring spot on 32mm. Now we're going to go in with our internal grooving tool and cut the groove for our snap ring. And for this groove I'm going to be using an internal 1.2mm insert. So that's the ID completed. Now we can machine the OD for our forming profile. And to machine that profile, I'm going to be using a TCMT insert. I'm not really happy with that surface finish, so I'm going to index the insert around to a new edge and hopefully clean that up. Now I'm going to change out to a TNGG insert and clean up the face. Last thing we need to do is part this to length, but I'm going to chamfer the back edge before we completely part it off. Yeah, just chipped it. Now that part's made, we can assemble our tool. So I thought that bearing would actually go in a little bit easier. Maybe when I machine the OD it's slightly pulled out of shape, but I'm just going to use a socket and a hammer to tap it into place. Righto guys, so that's our tool completed. I'm really happy with how that came out and it's going to work fantastic for the job we need to do. And this only really cost me time on the lathe and the mill. All the other parts we had lying around. The material wasn't off-cut from a job. The circlip kits came from the Yunnan lathe we got from auction. And the ball bearing I've actually had in stock for many years. It came from my old drifting days when I used to replace the clutch or the gearbox in my S15. I would replace the spigot bearing and that's where that came from. And now that we've got the tool made, we can get on to doing the job. Drop it. Drop it. Homie. Okay. So the first thing we need to do is take this over to the press and press in the sleeve. Now that's pressed in, we're going to take it over to the lathe and get it set up. And I have already gone ahead and changed out the chuck jaws on the lathe to the external jaws so we can grab the outside of the support carrier. And I'm just going to chuck the dial indicator on the face to make sure it's running true. And just out of curiosity, I'm going to take a measurement of the diameter of the groove, then I'll take a measurement after to see how far we moved it. And our starting diameter is 117 mil. This process is pretty quick because of how soft that material is. It doesn't take much at all to deform it into that groove. So what I need to do first is go in and find the center of the groove, then I can touch off and zero out the digital readout. So we're going to spin it slow. Because this material is so soft, a lot of this is going to be done by feel, and you do need to be pretty careful. If you advance the tool too far, you can cut that bearing completely in half. As I'm advancing the tool, when I feel a lot of resistance coming back through the cross slide, I know that material has firmly been seated into the groove of the support carrier. Then I just move the carriage forward and back about 1/2 mil each way to make sure that groove is fully formed. And honestly, that takes less than a minute and that is done. And now that's measuring at 118 mil, and that's all it takes to deform the bearing enough to lock it in place. But the job's not done just yet, we still need to machine that bearing to size. The finished diameter of our bearing is 114.41 mil. We only have 0.4 of a mil to remove, so we're going to take it very steady. Because this is such a soft material, without the right parameters, it is like machining Play-Doh. So I'm using a very sharp insert. I've upped the RPM, reduced the feed rate, and I'm using straight cutting fluid instead of coolant. We're getting close to size, so I'm going to use my bore gauge, which we've already set to the finished diameter, to see where we're at. So we've got 0.1 of a mil to remove. I'm going to take 0.05 and then we're going to check our measurement again, because I really don't want to overcut this. If we do, we'll need to replace the bearing. So I've still got 0.05 to remove, so we're going to take our final cut. So we've got that measuring spot on, and the tolerance we had to work within was plus or minus 0.013 of a mil, and we are well within that. So that's this job done and another tool made for the workshop. Hope you enjoyed it. Thanks for watching. I need to get rid of this spider web that's attached to you.
Attached to me?
So the OEM does supply procedure. So they are right. So
Jesus Christ.
Right, let's do it.
Okay.
Right. So they are so you just gotta slap yourself in the face every time you reset.
I can help with that if you want.
Were you recording that? Yeah. Oh my god. Now we've got that bearing pressed in, we can take it over to the bearing sleeve. Now that we've got the bearing sleeve,
This is going well.
that is also used for deforming the bearing. Oh, fuck me. Oh my god, I can't even speak a word.
You got this?
Right. What was that? It's me. It's not the words.
Let's get this done today.
Righto. And I'm going to machine that down to... Oh, fuck me. Righto. Wait. Righto. Because... oh, wait, that doesn't make English either. This is frustrating.
I get to re-listen to it all.
Lucky you. So I got that measuring spot on, really happy with that. Our tolerance we had to work with was 0.013 of a mil, and we are in that, so we are amazing. Now we're going to bore... Give me a minute. The fucking Christmas fucking thing flew in. Now we're going to bore it to size, and I'm going to be using a... Fucking banging your shit around, dude.
Alright, try again.
Right. And after we've... then I... How many more months of that have we got?
3.
As I'm advanced... Oh, fuck me.
This is great.
Can we just stop for the year? That shit's gonna blow our fucking minds out. It fucking will.
Okay. As I'm advancing the tool.
Right. Right. As on... Oh, fuck.
What is going on?
I don't
Please.
know. I'm
Just
fucking
repeat.
annoyed.
Let's go.
Right. As I'm advancing the tool... Oh, what was after that?
Oh my god. That noise isn't blowing my mind out. Curtis is.
What?